Oh, it's recording. Okay. Okay, so Gallup conducted a national poll asking, do you have a pet? Among women, 65% said yes. Among men, 74% said yes. You want to know if a similar result holds for the population of LBCC students. You claim that the proportion of women who have a pet is less than the proportion of men who have a pet at LBCC. You gather a random sample of 74 women and find 32 have a pet. You gather a random sample of 78 men and find 38 have a pet. Use the sample data and the steps below to test your claim at a 5% significance level. Round to 3 decimal places if needed. So part A, what is the null and alternative hypothesis? So the null hypothesis, you could either write it out as such, or you could use this notation, H sub naught. Either way though, the null hypothesis, since we are working with a 2 population proportion here, we're comparing the men versus the women, or women versus the men, is P sub 1 equals P sub 2. You start off with the assumption that they're equal. The alternative hypothesis, or you could use the notation H sub A, is that we claim that the proportion of women who have a pet is less than the proportion of men. So I'm going to do P sub 1 is less than P sub 2, where P sub 1 is the women and P sub 2 is men. It did not ask it here, but if it were to have asked whether it's left-tailed, left, right, or two-tailed, which is it? Left. Good. Even though it didn't ask it, I just want to include that for a bonus, okay? It's left because we're doing less than. It's going to the left. Calculate the difference in the sample proportions. Okay, sample proportions. So first off, we need the sample proportions. So we need P sub 1 hat and P sub 2 hat. P sub 1 hat, let's see, it said, you gather a random sample of 74 women, 32 have a pet. So that's 32 out of 74, and that will give you 0.432. Similarly, for the men, we got 78 men, 38 have a pet. So 38 out of 78, and that should give you 0.487. We are not done though, because it was not just asking for the individual sample values. Really, it wants the difference in the sample proportions. It wants the difference of them, which is telling us to subtract them. So P sub 1 hat minus P sub 2 hat equals 0.432 minus 0.487. Excuse me, thank you. Which once you do that subtraction, you get negative 0.055.
Does it matter what is P1 and what's P2?
If it doesn't like explicitly tell you which one should be which, typically just the order it appears is the order we just want to keep it in. Since we were talking about the women first, let the women be P1. And the men came second, so let the men be P2.
Okay.
Wait, why did we do that for the P cap?
Sorry, say again?
Why did we do that equation on the right side? What is that?
That is the difference in sample proportions. So the sample proportions, right? Sample proportions are these guys, right? That's the sample proportions. Now, when you hear the word difference is telling you to subtract them.
Okay, let's say on the exam it says that for difference.
Mhm.
You expect that
Yes.
equation to be pretty added stuff.
Yeah.
The normal CDF doesn't work. Did you guys get it?
Okay. Hopefully it works. I had gotten something, but maybe I did it wrong. So let's see.
Maybe I did it.
Okay, let's next do the pooled proportion. So remember, if you don't have the pooled proportion formula memorized, that's okay. It is on your formula sheet. Oh, and by the way, I'm on the Unit 7 side of the formula sheet. So the pooled proportion equals x sub 1 plus x sub 2 all over n sub 1 plus n sub 2. where the X's represent the number of successes for each population. So for the women, 32 had pets, plus the men, 38 had pets, over adding your n's together, where n was the sample size of each proportion. For the women, it was 74, plus for the men, it was 78. So you should get 70 over 152, which is 0.461.
On the test, will it specifically say like which one is P1 and which one is P2?
Not necessarily. In which case, just keep them in the same order. Okay, any questions so far?
What did you get? 70 over 152.
So, what we're doing here is it's really coming from this formula, x sub 1 plus x sub 2 over n sub 1 plus n sub 2. X sub 1 is the number of successes here, 32. 38 is the number of successes from the second population, 38 right here. And then on the denominator, you add together the sample sizes, which was 74 and 78. 32 plus 38 is 70, and then 74 plus 78 is 152. So then I add this across, add that across. Any other questions? Okay, next part D, let's find the standard error, which again, from your formula sheet, we are working with two populations from the hypothesis testing. So that means we need to use the standard error on the unit 7 side. Do not use the standard error on the unit 6 side. They are different. So standard error equals P bar times 1 minus P bar all over n sub 1 plus P bar times 1 minus P bar all over n sub 2. So you have the square root of 0.461 times 1 minus 0.461 all over the first sample size was 74 plus 0.461 times 1 minus 0.461 all over the second sample size, which was 78. Plug that into your calculators, rounding to 3 decimal places. That'll be 0.081.
I'm using P bar because it's too.
Yes. We're using 2 population proportions.
So how do you notice like which standard error you use on the exam? Like, which,
So the unit 6 side of the formula sheet is when you have 1 population proportion. The unit 7 side of the formula sheet is when you have 2 population proportions. Since we have 2 here, that's why I'm using this
so that's
one.
like what distinguishes that.
Yeah.
Okay.
Basically, it's whether you have 1 population or 2. All right, so let's find the z-score, which is also on our formula sheet. That is equal to p sub 1 hat minus p sub 2 hat all over the standard error. The difference of these sample proportions we did above. We did that in part B. We had gotten the difference to be negative 0.055. Over the standard error we just found in the previous step, so that's 0.081. Plug that into your calculator. I had gotten negative 0.679. Okay, part F, find the p-value. The p-value equals, really what is the p-value? It's the probability that your z-score is less than what we got here, the negative 0.679. And we know we're doing less than because in the very beginning, we said P1 is less than P2 and we said it was left tail. So less than, I already forgot what it was, negative 0.679. Negative 0.679. So what I want to see though is the normal CDF. The lower bound is negative 9999. Upper bound, negative 0.679, 0 and 1. Let me do it myself in my calculator because I don't know if I did it right. Second distribution, normal CDF.
Yeah, I did. I had a
0.679.
minus instead of the negative sign.
Oh, okay. little things, right? That should give you 0.249. 0.249. So, state conclusions about the null and alternative hypotheses. So remember, this is just like the in general. Do you reject or not reject the null? Do you support or not support the alternative? And why? But let's first start off with the why, okay? So our p-value, I'm going to rewrite it in percent form, is 24.9%. We were comparing it to what significance level? 5%. Okay. Is 24.9% less than or equal to 5%? No. So it is not, okay? 24.9% is not less than or equal to our significance level of 5%. Therefore, is it statistically significant or is it not statistically significant? Not. Good. Not statistically significant. Since it's not, okay, so again, this is a not, right? So 24.9% is not less than 5%. That means it is not statistically significant. So do we reject or do we not reject the null? Do not reject. Good. We do not reject the null. And do we support or not support the alternative? Do not support. Good. And not support the alternative hypotheses. Not.
That's gonna get me all the time.
Could you say what you said before, just how you said it out about it not being 24.9%?
Yeah.
Not less than or equal to 5%?
Yeah, that was exactly it. So our p-value, 24.9%, is not less than or equal to 5%, our significance level. Therefore, it is not statistically significant.
Because it is larger. Because it's larger.
Because it's larger, exactly. And then therefore, we do not reject the null and do not support the alternative.
Okay.
Yeah, so our p-value is not less than significance level, so it is not statistically significant. So we do not reject the null and we do not support the alternative. Not.
So if it was less than 5%, then all that would be yes.
Yeah, so that if it was, that would be like the first example we did. Where'd it go? That'd be like the first example we did here. The p-value is less than or equal to 5%. So it is statistically significant. So we reject the null and support the alternative. Those are the only two options. It either is or is not. Which are the exact same statements, just you throw in not, if it's not.
For the exam, we're gonna need to write it out.
Just
we're
like
gonna
how
do,
we're doing
word
here.
clouds like this, or
Just
we're gonna,
like,
bubble in, like
no, just like how we're doing here. Okay. So, let's continue with part E. State a final conclusion in the context of the problem. So, at the 5% significance level, the sample data do not support the claim, blah, 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 blah. You just copy whatever the claim was, which I forgot what it was. Let's go back to it. What was the claim? Right here. Okay, so here's the claim. I'm going to highlight it. You claim that the proportion of women who have a pet is less than the proportion of men who have a pet at LBCC. That was the claim. So we do not support that claim, right? The sample data does not support the claim that the proportion of women who have a pet, sample data do not support the claim that the proportion of women who have a pet, the proportion of women who have a pet is less than the proportion of men who have a pet at LBCC. Okay. So it is less than the proportion of men who have a pet at LBCC. Okay, so any questions on this problem? Okay, I'm gonna stop recording.